to the x over 3 equals 1 over 4 to the second. So then we can equate the exponents here and say x over 3 equals 2, and so x can equal, or will equal 6. That's not too bad? Nope. All right, next one. Now, I put a very large dot here to signify multiplication, and our 3 and 4 are different bases here, correct? The exponent on the 3 is 1, and 4 has an exponent of x over 2. We cannot multiply these together because they have different bases, okay? And so we must divide by 3 first. So we're going to get 4 to the x over 2 equals 32. Good. Now, I can get the same base here again on both sides, but it's not going to be 4. It's going to be 2. So this will be 2 squared to the x over 2 equals 2 to the 5th. And so when I multiply these exponents, because when you raise power to a power, you multiply. And then this will be 2 to the x equals 2 to the 5th, making x equal to 5. Nice. Okay. You know, I try to test the these.
I love it.
All right, moving right along. We're going to divide by 3. And this one will be 5 to the negative x over 4 equals 5. So we just say negative x over 4 equals
1.
the invisible 1 on the other side. So then x equals negative 4. I figured we'd start off really easy. Everybody got that?
Yep.
Moving right along. Now, this is a log equation. This is a log equation, log equal to a number. And where is the x? It's inside the log's argument. So we need to set it free. We have to exponentiate. You're right. And why are we going to exponentiate? Because that's the inverse operation. Okay, so let's exponentiate here. We're going to say, oh wait, why am I'm going to use, instead of e, I'm sorry, I'm seeing. This is 2. Right, the log and the log base 2 and the 2 cancel because those are inverse operations. And so then I get x equals 2 to the 5th and x equals 32. Okay? I have one down here. Bring it up for ease. This is a nested log. A lot of logs here. Okay, so this is still a log equal to a number. And so we are going to exponentiate. We're going to exponentiate from the outside in. So the external base is here 2. So I'm going to raise 2 to the both sides there. And the log base 2's cancel. And then I'm left with log base 4 of x equals 2 to the first, which is just 2. And then last one, we're going to exponentiate here with base 4. These cancel and we get x equals 4 squared or 16. So if you had one of these on the test that was 5 logs nested together, would you freak out? No, you just go one at a time. You have to exponentiate a lot of times but you get there. Okay? Now, this is another type of equation where you might have a log equal a log, but I have a coefficient. And you can't exponentiate if you have something in the path between the log and the number you're going to exponentiate with. So, I have to do something to 2/3 first. You have to raise it up. So I'm going to take this and bring it up to the top here. And so this is log base b of x squared plus 7 equals log base b of 64 to the 2/3. And we can actually simplify that, right? 64 to the 2/3 is the cube root of 64, which is 4 squared, which is 16. So we can say that this is equal to log base b of 16. Log base b of. Now, we have to do the inverse operation here, so we're going to exponentiate and that causes these to go away because they're inverse operations. And then I get x squared plus 7 equals 16. X squared equals 9. X equals plus or minus 3. Now, I caution you here, you can't take the log of what kind of number? A negative number. But this might be okay because if we go back to the original, it's squared. So are we taking, even if it wasn't squared, if it was something less than 7, you'd still be okay. All right, so this is okay. We don't have any extraneous solutions. So when you're solving log equations, you should check for extraneous solutions. And extraneous solutions occur when your argument is equal to 0 or less. All right? Moving right along. You have a prayer of getting the same base here.
Yes.
I mean, you're in a Catholic school. Who knows? Miracles could happen, but not here.
No.
Right? So we can take the log of both sides. Now, we have the log base something, or we have the ln base something, and which has fewer letters? The ln. Naturally, we'll use that one. Oh, boo, I know. I know. So I'm going to take the log of both sides, the natural log. When you get the same answer if you use a different base, the answer is yes. Okay, so what can I do with this x?
Bring it out.
Bring that out in front. So that'll come down in front, and I get x times the natural log of 0.98 equals the natural log of 1.6. Solving for x, we'll get the natural log of 1.6 divided by the natural log of 0.98. So before we stick this in the calculator, what kind of number are we going to get here?
Positive. Maybe.
Well, let's think about the log graph really quickly because I like to bring us back to tying things together with the graph. This is the natural log function. And between 0 and 1, what kind of number are you going to get? The log of a number between 0 and 1 is negative. So this is going to be a positive number in the numerator and a negative number below. So somebody give me this decimal, please. I'm sorry, negative 23.26.
Yep.
Okay. So I want us to be thinking about what kind of numbers we'll have, positive or negative. All right? Next one.
7.
Yes, we can subtract 7 from both sides. I like it. So this is negative 3e to the negative x equals negative 5 if I subtract 7. Divide by negative 3, we get e to the negative x equals 5 over 3. Take the natural log of both sides. I'm going to bring the negative x down here, and I'll do this one step here first, just to show everybody what we're doing. The natural log of e naturally is 1. So then this is negative x equals the natural log of 5 over 3, and that's x equals negative natural log of 5 over 3. Now this is the exact answer here. The approximate. Now, before we plug it in the calculator, we know the natural log of 5 over 3 is a positive number, right? And so what do we get here? Negative
0.5.
25.
1.
1. 1. Now, if you don't want to show this stuff and you can just go to negative x here, that's okay. I'm just showing this for notes purposes. Okay? Moving right along. This is almost a log equal a number, except it's not. What would you like to do first? Subtract 3. So we get negative log of x plus 2 equals 2. Good. I can't exponentiate yet. Why? Because there's a negative in front of the log. So this would be log of x plus 2 equals negative 2. And now we're going to exponentiate. And what base?
10.
Good, because that's the common log if it's not shown. And so then, since these are opposite or inverse operations, those on the left side, the log and the 10 go away. We get x plus 2 equals, what's 10 to the negative 2?
1 over 100.
You guys are like on today, it's great. So 1 over 100. So this is going to be x equals 1 over 100 minus 2, which would be 200 over 100, which would be negative 199 over 100. Got it?
Yep.
You're doing great. What do we do here?
It's 2. The 2 out. Right, both sides are mean.
This is dangerous, this problem. You can pull a star by it. It's tricky. If you bring the 2 down, let's think about it.
Would that have to be?
If I bring the 2 down, that's 2 natural log of x equals 4. You can divide by 2,
L out of x equals 2.
right? And then you exponentiate, you get e squared, correct?
Yes.
But what plus or minus e squared work here? Yeah. Okay, so what I'm going to do is show you that, yes, you can bring the 2 down here. This is the way not to do it. I'll say not this way. Bring down the 2, and we say, is it wrong to bring down the 2? No, I mean, with the properties of logs, you can do that. That's not a problem. What happens in solving this is now I divide by 2, I get ln x equals 2, and then I exponentiate with the base e. And then these cancel out because they're opposite operations, and we get x equals e to the second. Okay? But what happens if we, this is the way, right? This way. I'm going to put big letters. What happens here if we take natural log of x squared equals 4 and we exponentiate it right away? We get
Squared equals e.
x squared equals e to the 4th, and x will equal then plus or minus e squared. Which the negative works in here. Now this, let's think about what the graph of this looks like, you know, because I like to think graphically, and I want you guys to start thinking graphically. If you're graphing ln of x squared, we're going to not look at the calculator, right? We're just going to graph this. It's going to look like this side. It's going to probably look like this. But can I put in negative numbers now with this being squared, the argument?
Yeah.
So what's going to happen is it's going to be it's going to be reflected here. And I'm not going to do this to scale because clearly it might not be. God bless you. What happens if I let y equal 4? Oops.
You'll get a negative and positive.
You get a negative and positive answer here, graphically. You see what's happening?
Yes.
And this is going to be e squared, and this would then obviously be negative e squared. Okay, so this is a danger because your original will allow you to plug in what kind of numbers? Plus or minus. So watch it. If this is an even exponent, exponentiate it before you bring down any exponents. Okay? So what did we do here? We lost a solution. Lost a possible solution. All right, moving on. This was everybody's favorite this morning.
Really? Oh, wait.
No. That's a false good.
Okay.
So what are we going to do first? We're going to multiply by 2, right? Because we want to get rid of the denominator. And we'll say 2 to the x plus 2 to the negative x equals 6.
Okay.
And we can solve this graphically. We put it in the calculator and put 1 on the left side and y1 and the other in y2. We get a solution. Okay, but algebraically, we need to figure it out. So I'm going to move the 6 over. So we'll get 2 to the x plus 2 to the negative x minus 6 equals 0. And so I would like us to factor out the 2 to the negative x, because something nice is going to happen when we do that. You know, it doesn't feel like it's going to be nice in the beginning here. So I factor out a 2 to the negative x. What's standing in the 2 to the negative x spot?
1.
Everybody agree that that's 1?
Yeah.
Yeah, that's good news. Now, if I'm going to factor 2x minus 4 and factor a 2 out here, this will be x minus 2. What did I do to this 4 to get the 2? You divide it. So then I'm going to say this will be 2 to the x over 2 to the negative x, and then minus 6 over 2 to the negative x. But when you have a negative exponent in the denominator,
1, you can smooth it.
right, or you can subtract the exponents, right? So it would be x minus a minus x, which is 2x. So this would be 2 to the 2x. Now I'm going to put them in a different order. Minus 6 times 2 to the x. Good, because if it's parked in the wrong space here, down here, because it's got a negative exponent, it really belongs to the numerator. Plus 1.
Wait, what?
I'm sorry, what?
Never mind.
Okay, does this look like something maybe might be? It looks kind of quadratic. What's x here? If you were thinking about it in the typical sense. Quadratically, it would be
2x.
x squared minus 6x plus, right. So in your mind, could you rewrite this similarly to like 2 to the x quantity squared minus 6 times 2 to the x plus 1 equals 0? Could you do that?
Yeah.
Right? And then if we were solving this ax squared plus bx plus c, setting it equal to 0, we'd use the quadratic formula, which would be x equals. So what are we going to do instead of having x equals here?
Yeah.
It would be 2 to the x equals. And yes, we could use u sub, but I challenge you to not need u.
I got it.
You got it?
Okay.
So what, it's going to be 2 to the x equals, well, what is a here? Let's think about it. What's a? 1, good. B is negative 6. C is 1. So now we're going to use the quadratic formula to solve this part, and then we'll talk about the 2 to the negative x out here. So it's 2 to the x equals the opposite of b, which would be 6 plus or minus the square root of 36. Minus 4 times 1 times 1, all over 2a, which is just 2. So this is 2 to the x equals 3 plus or minus the square root of 32, which is 16 times 2. 4 root 2 over 2, which equals 3 plus or minus 2 root 2. So I have two equations here. I have 2 to the x equals 3 plus 2 root 2. And then I have 2 to the x equals 3 minus 2 root 2. How do we solve those? Naturally, we should take the natural log of both sides. And I get x times the natural log of 2 equals the natural log of 3 plus 2 root 2. X equals the natural log of 3 plus 2 root 2, all over the natural log of 2, and that's going to give us a number. And then this one is going to be the same answer, except it's going to have a negative sign. So x natural log of 2 equals natural log of 3 minus 2 root 2. X equals natural log of 3 minus 2 root 2 over natural log of 2. And so if we get x equals, so we need a beautiful number here to the plus 1.
2.54.
Good, 2.54. Now, my only concern here is now, is that 2 root 2? Because it's negative, that's gonna, are we gonna have a negative number here in the log? So, 2, or root 2 is 1.414, so 2 times that will be 2.828, so I think we're gonna be okay. So what do we get when you do this? Yeah, I think it's going to be pretty symmetrical here. Yeah. Which is nice. Okay, now, those are our two answers, and then we have one other factor to consider, which is 2 to the negative x equals 0. What happens here? We take the log of both sides, and I get ln 2. I'm running out of space. Wait, can I take the log of 0? No. Think of the graph here. 2 to the negative x. What does it look like? 2 to the negative x. That's the same as 1/2 to the, yes, that's right. Sam, you're right. Here we go. Is that ever 0?
Nope.
Not in a million years. So this is no solution. And I mean in a million years because, right, it's going to keep going, and closing, but never get there. Like it's taunting 0. Never going to make it. Okay? Got it?
Got it.
Next. Sometimes you don't have to factor out a negative like an exponential with a negative exponent. Sometimes you can just factor. Two e to the x and e to the x.
Plus 3 next to it.
Okay, plus 3 and
No,
oh, we're okay,
minus 1. But plus 3 is 2 e to the x minus 1. E to the x
plus 3 and
minus
minus 1. Okay, gotcha. All right, so let's talk about this one. This is 2 e to the x minus 1 equals 0. 2 e to the x equals 1. E to the x equals 1/2. How do we solve that? Natural log, so we're going to say natural log of this, natural log of this. And we have the longest bells in history. X equals the natural log of 1/2, which you could expand and say natural log of 1 minus natural log of 2. because it's division. And the natural log of 1 is
0.
0. So x equals negative natural log of 2. And before you ask on a test, I would accept either natural log of 1/2 or negative ln of 2. Okay, so don't forget about that. All right, what about the other side here? We get e to the x plus 3 equals 0. E to the x equals negative 3. Mr. Turco shaking his head, no way, Jose.
You can't take the natural log and negative.
For all time, yes, you'll be able to do it. Okay. What happens here? E to the x looks like this. Negative 3 is way down here. Do they ever intersect? No, and if you wanted to algebraically prove it to yourself, can you take the natural log of the negative number? And the answer is no. So this is no solution on this side. We have only one answer, which is negative ln of 2. Logistics, we've done this already. What do we do? Solve for x, cross multiply. So we get 150 times 1 plus 95 e to the negative 0.6x equals 400, and you guys did pretty well on the quiz. So 1 plus 95, I'm going to divide by 150, and I'm going to get rid of one of my zeros, if that's all right with you. And then I'm going to subtract 1. 95 e to the negative 0.6x equals 40 over 15 minus 1, and then divide by 95 or multiply by 1 over 95. You notice I'm not simplifying, so I'm going to just put it in the calculator. And then we take the natural log of all of this, and we get negative 0.6x equals the natural log of 1 over 95 times 40 over 15 minus 1, close parentheses, and then divide by negative 0.6. Very nice. I don't know if anybody's gotten ahead of us and done that, but
6.74.
0.74?
6.74.
6.74. Thank you. Questions on that? What do? We just cross multiply and get the x all by itself. It looks messy, but not too bad. Here, I have 2 logs on one side, so I need to condense first and get a log equal to a number. So what do I have to do with 1/2? Raise it up to the top here. And I get log of x minus the log of, and this will be the square root of x plus 4, right? Because it's 1/2 equals 1, but I'm subtracting on the left. So when you're
You
right, so this would be log of x over the square root of x plus 4 equals 1. And now I have a log equal to a number, so the strategy is exponentiate with base 10. Very nice. With base 10. And the left side of log and the 10 cancel, and then we're left with x over the square root of x plus 4 equals 10. Now we're going to have to cross multiply. 10 root x plus 4 equals x. And at this moment, I'd square it right here. I mean, I like squaring 10. We get 100 times x plus 4. Now, when you square something, what do you increase the risk of? Some extraneous solution, so we have to be on the lookout for that. And we'll finish after lunch. Hopefully you'll be pretty quick.
It's capturing your screen, that's capturing your screen, that's capturing.
Oh, the inception of screen capture. All right, so we're going to continue this with part 2, which we were ending right about here, I believe.
Yeah.
Before pesky lunch got in our way. Okay, so we squared both sides, introducing the possibility of extraneous solutions, but we're not going to worry about that. I'm going to distribute this 100x plus 400 equals x squared. I'm going to set it equal to 0 by moving everything to the right. 0 equals x squared minus 100x minus 400. Sadly, this does not factor. We could complete the square.
That would be hard.
I think
Let's
okay,
do it.
okay, x equals 100 plus or minus the square root of 100 squared minus 4 times 1 times negative 400 all over 2a, which is 2, and then 2 here. And then x equals 50 plus or minus, now the square root of, this is 100, this is 11,600. Can somebody do that on the calculator? Before you take the square root, is it 11,600?
Yeah, no, yes.
Yes?
Yes. 11,600.
Square root of over 2. I know I can take the square root of 100. Which would be 10. I can bring 10 out here, and then it's 116. And I know that a 4 will go in there. 229.
Yes.
Okay, so then this will be plus or minus 40 over 29 over 2, 50 equals x equals, and then 50 plus or minus, that's going to be 20 root 29. Now, what we're going to do with this?
Make sure.
We go back to the beginning. In the beginning, there was an equation. Okay, so it has to be positive.
Yeah.
So
It can't be.
is 20 times root 29 bigger than 50?
Yeah.
It is. So we have an extraneous solution, don't we? X equals 50 plus 20 root 29 is the only answer. Do 50 minus 20 root 29 on your calculator. How does this work? Well, think about it. What's root 29? Well, I don't know root 29, but I know that it has to be bigger than 4.
Negative 57%.
Bigger than 5 even, yes.
Yes.
And 5 times 20 is what? 100. 100. So we know it's negative. So we know that's extraneous. So we have only one solution there. Okay? All right, now graphically, what's going on here? I love this one. We already know what 24 is, don't we? It is B. Everybody agree?
Yes.
And then what does A have to be? 23. Everybody agree with that? You see how they're different?
Yeah.
Okay, then I have this one here, x times x plus 1. Let's do a sign chart for this one, for number 19. We're going to do a sign chart for number 19. When is the argument equal to 0?
Negative.
0 and negative 1. And what kind of function is that in the argument?
It's quadratic.
It's a quadratic, yes, Mark, you're right, quadratic, and it opens up. So the log can only be of positive numbers. So the domain on this one is negative infinity to negative 1, the union with 0 to infinity. So it's going to be E. Do you agree?
Yeah.
So this one is 19. All right, so let's do 21. Let's do a sign chart for the domain here. When is this one 0? So 0 when x is 0. It's undefined when x is negative 1. So I'm going to, oops, that's a 1. I'm going to put an open dot here, and I know that's an asymptote of some sort, okay? And what kind of shape or curve is the numerator?
Line.
It's a line with a positive slope. So there it is. And then the denominator is also a line with a positive slope. So what's my sign chart here? We have negative and a negative on the left, positive and then negative and then positive. So this one has the same domain as 19. Well, did you say D as in David?
Yeah.
How do we know, all right, we'll say this is 21. How do we know that that works?
Yeah, I was thinking it's a rational function.
Okay, so, okay.
What if 0? What if 22 was a lot like that?
Just a minute. Let's think about this. This is always going to be what number? What kind of number? A number less than 1 when x is bigger than 1. Do you agree with that?
Yeah.
Or x greater than 0. It'll never be 1. So it's going to be a number between 0 and 1, which is what kind of number? A fraction?
Fraction.
Which means that the log of a fraction is what sign? Negative. So it's going to be negative on this side.
Yeah.
Okay?
Okay, that's fine.
Got it? That's why that one works. Let's do 20. We did 23. The domain on this one here. We have, has to be greater than 0. And this one says, but I can only have numbers that are bigger than negative 1. So which one is the most restrictive? So this one has a domain from 0 to infinity.
That is left.
I'm gonna do A.
You're going to go with A.
Oh, we already have it.
You already
C
have
and
it.
F, sorry. Well,
Well, let's think about the logic here. When you combine them, what do you get? Multiplication, don't you?
yeah.
So that's going to be a number that's probably, when x is greater than 0, bigger than 1, maybe?
Yeah.
So that's always going to be, we're going to have some positive action going on.
Okay. So yeah.
I think it's F. What do you think?
I can agree with that.
What number was that? I forgot.
20.
What?
When you simplify 20, don't you get the same thing as 19?
You do, except that the domain is from the beginning.
Oh, yeah.
Right? In the domain here, I've got some multiplication to consider that'll give me some positive area here. I'm not multiplying here, you know? All right. What about 22?
It's
It has to be C. Why? Because this is division again, and this would be the log of x over x plus 1, which is a number that's always, it's a fraction, which would be less than 0. So this one has to be, what's this number?
22.
22. I might have helped you with your homework here, because I got this from the book. And then I'm gonna let you guys do the law of cooling, because this is very much like your problem of the week. And I just would change this to S, because I like the surrounding temperature to be T sub S. Okay, and that's the way it is in calculus, so then you'll have a formula already figured out, all right? So that's all I have for you today.